Have you ever looked up at the night sky and wondered, how did it all begin? What if everything you thought you knew about the universe's origin is just scratching the surface of a mind-bending truth? Join us as we unravel the perplexing cosmic birth of everything, inviting you to ponder the enigmatic beginnings of space and time. Imagine the ultimate void, not just empty space, but a state before space itself, before time, before matter. It's a concept that challenges the very limits of our imagination. What existed before everything? This is the ultimate philosophical and scientific riddle. The profound question of nothingness versus somethingness. How can a universe teeming with galaxies, stars, and life emerge from? Well, what? This is the stage for the most epic origin story ever told. The story of our cosmos. Now, let's talk about the Big Bang. But forget the simple idea of a cosmic firecracker. It wasn't an explosion in space. It was the explosion of space. Picture this. The entire observable universe, all the energy and matter we see today, compressed into a point of infinite density and temperature, called a singularity. Then, in an instant, it began to expand. Not just expand, but expand with breathtaking speed and precision. The conditions in that first fraction of a second had to be just right. A tiny bit more density, and it would have collapsed back on itself. A tiny bit less, and it would have flown apart too fast for stars and galaxies to ever form. We're living in a Goldilocks universe, and the evidence is all around us. How do we know this isn't just a wild guess? We have cosmic fingerprints. One of the most powerful pieces of evidence is the cosmic microwave background radiation, or the CMB. Think of it as the faint, leftover heat from that initial fireball, a baby picture of the universe when it was just 380,000 years old. This ancient light fills the entire sky, a consistent glow that tells us the universe once was incredibly hot and dense. Then there's redshift. When we look at distant galaxies, their light is stretched, shifted towards the red end of the spectrum. It's the same effect as a siren sounding lower as it moves away from you. This redshift tells us that galaxies are flying away from each other, and the farther they are, the faster they're moving. The universe is expanding, just as the Big Bang model predicts. But the standard Big Bang model had a few nagging puzzles. For instance, why is the universe so remarkably uniform and geometrically flat on large scales? The answer might lie in an even more mind-boggling event called cosmic inflation. In the very first whisper of a moment after the Big Bang, the universe is thought to have undergone a period of hyperfast exponential expansion. It inflated faster than the speed of light, smoothing out any initial wrinkles and stretching space to be almost perfectly flat. This isn't just a convenient patch. It's a powerful theory that solves major cosmological problems. And here's where it gets even stranger. If inflation happened, it might not have been a one-time event. Some theories propose that our universe is just one bubble that inflated out of a larger, eternally inflating multiverse. Imagine an infinite, frothing cosmic ocean, where new bubble universes are constantly popping into existence, each with potentially different physical laws. Are we just one island in an endless cosmic archipelago? Scientists are actively searching for evidence, like specific patterns in gravitational waves from the early universe, that could prove or disprove these incredible ideas. It pushes the boundary from science fiction to potential reality. As if that weren't enough, about 25 years ago, astronomers made a shocking discovery. Not only is the universe expanding, but its expansion is speeding up. Something is pushing everything apart, acting like a cosmic anti-gravity. We call this mysterious force dark energy, and it makes up nearly 70% of the entire universe. But what is it? Is it an inherent property of space itself, what Einstein called the cosmological constant? Is it a new, dynamic energy field called quintessence? Or does it mean our understanding of gravity is fundamentally wrong? We just don't know. This accelerating expansion has profound implications for the universe's ultimate fate. Will it continue to expand and cool forever, leading to a big freeze where all stars burn out and the cosmos becomes a dark, cold, empty place? Or will this mysterious dark energy grow stronger, eventually becoming so powerful that it tears apart galaxies, stars, and even atoms themselves in a big rip? There's also the fascinating possibility of a cyclical universe, a big bounce, where the universe expands, then contracts, and is reborn from its own ashes, over and over for eternity. The destiny of our cosmos hangs on the nature of this dark energy we've only just begun to study. This brings us to the edge of human knowledge, the frontier of our understanding. Our current physics breaks down when we try to describe the very first moment, the Planck epoch. In this realm, the forces of gravity and quantum mechanics, which we describe with two different sets of rules, must have been one. To understand it, we need a new theory, a theory of everything, that can unify all the fundamental forces of nature. This is the holy grail of modern physics. The search continues, reminding us that for all we have learned, we are still just beginning to grasp the full story. Contemplating these cosmic mysteries fills us with a sense of wonder and humility. We are a part of a universe that is grander, stranger, and more beautiful than we could have ever imagined. The quest to understand our origins is one of the most profound journeys we can take. Thank you so much for joining us on this incredible exploration of our cosmic beginnings. If your mind is as expanded as ours, don't forget to hit that like button, subscribe to the channel, and ring the bell so you won't miss our next journey into the great unknown. What part of the universe's origin story fascinates you the most? Let us know in the comments below. Until next time, keep looking up.